to form benzene sulfuric acid. And we did the mechanism, and yeah, we saw how an electrophile is generated, the SO3, and we actually saw why the SO3 is our electrophile and how it is going to receive electrons from the ring, and how the ring is going to behave, okay, until when you form the final product. So today we are going to begin with halogenation of the benzene ring, and it's the same thing. Like I told you, benzene undergoes electrophilic substitution reaction. So even it is the same thing. The logic is generate an electrophile. And after you've generated an electrophile, then the electrophile is going to receive the electrons from the ring. And the receiving is the same. But as long as you have generated your electrophile, then you are okay. And in this case, for instance, the halogens also react with benzene. But now, they don't just undergo addition reaction. They don't just add themselves across a double bond. They also undergo substitution reaction, whereby you first generate an electrophile. Okay? And how are you going to generate an electrophile? Since it is just it is halogen, same electronegativity, same charge density of the two atoms. What do I mean? I mean, if I do chlorine and the chlorine is bonded to chlorine, these are atoms of the same element, and so these atoms have the same electronegativities, same electron densities, same charge densities, everything same. And so it's hard to induce, okay, these reactions to react with benzene. And so for them to react with benzene, then you must have a halogen carrier. Okay? And it is this halogen carrier that is going to induce, okay, these two halogens to gain charges. Okay? To be able to react with benzene. It is the halogen carrier that is going to induce one chlorine, or one bromine, or one iodine, okay, to have to form an electrophile and a nucleophile, whereby now an electrophile is going to receive the delocalized electrons from the benzene. So what is that halogen carrier then? There are commonly three known halogen carriers. And the first one, we have aluminium chloride. You can use this, or aluminium bromide, or aluminium iodide, depending on what you are reacting with. You can have iron 3 chloride. Now these halogen carriers, they are Lewis bases. They have electrons, they are electron rich, okay, and being electron rich with vacant orbitals, I think, they can induce, okay, they can induce the two bromide atoms, the two chloride atoms, one to gain a negative charge and another one to gain a positive charge. So that's why you have aluminium chloride, highly electron rich. The electron density is so high. You can see. Iron 3, the electron density is so high. Or we can generate them. Boron 3 fluoride, the electron density is so high. Or we can generate them. Okay? You get a mixture of iron and chlorine, and then you heat. You produce iron 3 chloride. So depending on what is given, if you are given this, then you won't need to heat. But if you are given iron, and then chlorine, then you first generate the electron carrier, and then the reaction proceeds. And we are going to do that. Now, in absence of an electron carrier, a halogen carrier, then there is no way how benzene is going to react with the halogen, because those electrons are not available for bonding. They are not just pi electrons, just like those electrons in alkenes. And so what does that mean? You must first form an electrophile to be able to induce the benzene to donate the electrons. Okay? However, in presence of sunlight, in presence of UV, then the benzene undergoes substitution reactions, where it will form not substitution. It will undergo reactions to form we shall find it down. 1, 2, 3, 4, 5, 6. A halogen compound. Hexa halogen or something compound. We shall find a reaction down. Okay? Why? Because the UV light is going to induce our halogen, okay, to undergo homolytic fusion to produce radicals. And remember, we agreed that radicals, they are highly reactive species, so they can induce the benzene to react. Is that really okay? Let's see. Let's do some mechanism. We have our benzene. Okay? We have our benzene. Now when you're writing benzene, like I told you, so I told you, if you're writing benzene, all these sides must be equal. But now, because me, I'm just typing, I'm using a touchpad, I can be excused. But all these sides must be equal. So the benzene is going to react with our halogen in presence of a halogen carrier. It could be iron 3 chloride, it could be aluminium chloride, and so on, as long as it's a halogen carrier. And then we shall form our chlorobenzene. It will undergo substitution reaction, and we form chlorobenzene. And so this is a full mark, because the question will be like, copy and complete the equation. Now, most of you like to write the mechanism without completing the equation. Then you lose the 1 mark. So now what happens here is, before you even think about the chlorine reacting with iron, the chlorine, okay, the halogen carrier is going to induce the chlorine, okay, to form partial charges or to form charges, okay, whereby it will receive, okay, the electrons from this chlorine, and we form one chloride that is electrophilic, okay. I'm safe. I hope it's not corona. So this bond is partially broken, okay? It is still there. And then with your iron, okay, that has received 1 chlorine, okay, but is also partially negative. So now this is our halogen carrier, our iron, which is a halogen carrier. Okay, I hope it's okay. So which is our halogen carrier. Now you have successfully induced, okay, you have successfully formed an electrophile. This chlorine, this one, it is unelectrified. Now that's where your benzene is going to come in. Okay? Now the benzene is going to dive in. Like I told you, if you are writing benzene, all sides must be equal and these crosses shouldn't be there. But I can't rub. If I rub, everything goes. So that's how you would excuse me. So this will be Cl and then partial charge and then a bond and then iron, which is our halogen carrier. Okay? 4 and then partially negative. So now the benzene, let me even do this with a different pen. So now this benzene is going to donate. I said when you are writing these arrows, they should be bent. They should be bent a bit. Don't do this. Now here I will do this. No, that one is not good. It should be bent a bit because arrows show how electrons move, and they should have where the point where it comes from. You can see it has a point where it is coming from, and it should also have a point where it ends. You can see. So even here, then this bond is going to break, and now it becomes a complete negative charge. So that now, what shall we form? Then now we shall form our ring. Okay? Our ring with a chloride atom. Okay? With now this hydrogen was there. Okay, it was there is hydrogen. So when this Cl attaches, even the hydrogen attaches. Now since we are using this ring structure, the one that shows the localization of electrons, then you represent it as this. You do have that points on where the Cl has been attached, and then you put a positive charge. Is that really hard? Am I asking for too much? Really, it's not too much. And then plus our halogen that has been formed. Okay? Halogen carrier. This is CH4 with now a minus. Okay? That's brilliant. So now this is now a nucleophile, electron rich. So it will come and take away the hydrogen. So this is Cl4 minus. And when you are writing, let note the letters B. You see how mine they are attached. This is not good. So it will come and take away, maybe let me change a pen. It will come and take away the hydrogen. Okay? And then this bond, it goes back inside to delocalize with other electrons. And so what shall we form? We shall form our Cl, our benzene, okay, with a full circle, and then the Cl here plus the hydrogen chloride. But like I told you, in organic chemistry we focus on the organic part. So even if you don't write this HCl, you will still earn the marks. So when you are marking, we shall put a mark here, we shall put a mark here, and we shall put a mark here, and for the final product, and then for completing, depending on how many marks the question has. So now you try out this. Let me write it with this pen because it will disappear. So you try out this. You have your benzene. Now let me give you the one with bonds, and then the benzene reacts with Cl. This is for your own trial, and iron, and then you must do the heating. So you try out that. Chap chap. Please hurry up, hurry up. Yeah, thanks for the work that you've done. Now let's do the correction. I've seen what I wanted, like I told you. So the product here is going to be chlorobenzene as usual. Somebody gave it as a name, and that is pretty good. So this is...
Just share the screen.
Oh,
Teacher.
it's okay, I'm not sharing. Yeah, sorry. So I hope you can now see my screen. So our product is going to be chlorobenzene, where this is the bond. So also, the way you write your benzenes, it's not yet there. You are not yet there. So this is the Cl. Okay? That's the Cl. So this is the product. And if the question says copy and complete, then you earn 1 mark for completing. Strictly, even without saying your mechanism, you earn 1 mark for completing. So now the mechanism, it is going to be just simple. Now here, I've not given you the halogen carrier. I've just given you chlorine and iron, and then the heat. So the first thing that you do is to synthesize a halogen carrier. And how do you? You react iron, okay, and it's a solid, with chlorine gas, excess chlorine gas, then you shall form the iron 3. Now I saw some people with iron 2. Now chlorine being a high oxidizing agent, it will induce iron to react with its maximum oxidation state. Okay? So that's why we form iron 3, not iron 2. Now the iron 3 that you formed, now that is a halogen carrier. Then it will induce the excess chlorine. Okay? It will induce the excess chlorine now to form the partial charges. Now the rest becomes normal. Okay? The rest is just normal, like the previous mechanism. So it will induce this chlorine to form charges since it has a high electron density. Okay? So it will induce the chlorine to form the partial charges, where it will have the Cl and the one that has given up on the electrons to gain a partial positive charge. Oh, now I can't rub this. If I rub, everything goes. So sorry for this. This is a plus. Let me use some different pen now. So this is a plus, partial positive charge, and then a partial bond. Okay? Then Cl minus. Not Cl but iron. Okay? Cl4 partially minus. So now this electrophile now, it can now receive electrons from the ring. Okay? So where your ring now comes in, so that's my ring. Make sure when you are in a paper, you write a good ring, otherwise I will cross you. So this is your ring, okay? And this is the Cl, and then this is our F, okay? And then this is the Cl3, Cl4 partially minus, and this one is partially positive. So now it will receive electrons from the benzene. It will receive electrons from the benzene, and then this one breaks and it goes to chlorine, not iron. Now some people will tend to put it here to do this, and they put it on iron. That is not correct. Here it is iron that is inducing the formation of partial charges, that is polarizing this chlorine molecule. So the arrow goes on iron and you form this. But now here, it is the other partially negative chlorine that is now taking away the electrons. So you cannot put the arrow on iron. Not so? That's brilliant. And so what shall we form? Then we shall form our benzene, okay, that has lost its electrons, okay, and you have this bond, and you also have this, but now here you have there the chloride atom, and here you have there the hydrogen atom, and this carbon atom has lost its electrons, okay. The plus is on this carbon, this very carbon. Now note the difference. When we use the delocalization, the ring, when we use this circle, we did this, okay, and we put a plus in the middle, and it points where the Cl has been attached. But when you use bonds, then you put a charge on that carbon atom that has lost the electrons. Then now your nucleophile comes in, okay, the nucleophile, which is HCl4, okay, comes in, HCl4 minus, and donates the electrons to this hydrogen atom, and then the two electrons that were making this carbon hydrogen bond, they are donated back to the ring to delocalize with the remaining electrons. Not so? And so what shall we form? Oh my god. So what shall we form? Mind about this. We shall form our benzene, which is a final product, our chlorobenzene. Now, okay, I'll comment this after. Cl and then plus the hydrogen chloride gas. So it is as simple as that. So most of you neglected this, and most of you, this step gave you a bloody nose. Now, once you are given in a question this, and for you use this benzene, this ring, then you lose marks. And once you are given in a question this ring, and for you use this, still you lose marks. So always maintain what is given. Not so? Yes. Any queries?
Teacher,
Yes?
the two electrons from the hydrogen bond,
Mm.
they are going to the positively charged carbon atom.
You want us to do this? You want us to do this? No, they are taken back inside the ring to delocalize. Okay? That's why the
Okay.
arrow is taken inside, but not specifically on this carbon. They are taken back inside to delocalize. And so in other words, also this carbon atom is going to be balanced again. Does it make sense now?
Yeah, it does.
Good. Any other question? Another question? Before I wrap everything?
Teacher, the last one.
Yes.
I have some friends who do their mechanism differently from us.
Like how? You want to show us?
You see, let me just show that one let me first write for the Korean bond only.
It's okay. You write and show us. I have a look. So this is your concern. They write Cl, and then this is another Cl, and then they include their own pairs. Okay, that's 1, that is 2, this is 4, this is and then the same applies to this. That's 1, and then that is 2, and then that is 3. Okay, so they include their own pairs, and then FeCl3, and then they do this. After, does it detach? You want to detach the whole of it, and you form Cl
Yes.
with and then this, and then this, with a positive, and then plus the iron. It was this one, iron Cl,
Yes.
iron Cl with a minus. This is a 4. It was this one,
Yes.
So no, here,
Teacher,
yes,
even you see for the iron,
for the
the iron there, they separate the iron 3.
they
They
say
separate it and put all the three bonds of chlorine there.
they write iron, and then
Yeah, then they put all the 3 bonds.
they just put 3, and then where is the fourth?
No, no, there are 3 bonds. Okay, oh, fourth, yeah. Also, they put all the 4 bonds,
And
but it should be bonded.
they just distribute.
Yeah, they distribute. Then when you remember when we're changing the negative what? The negative chlorine. When
uh,
we're taking the electrons of that chlorine the other side
mm,
to the benzene ring.
mm,
They they show the bond exactly where it is coming from.
mm,
They show the bond, the exact bond,
mm,
then to the benzene ring and everything.
mm,
They say that when I showed them my mechanism, when we're
mm,
still doing alkyls,
mm.
they say that mine was wrong.
Oh, that yours was wrong. No, it wasn't wrong. Now here, this now here you are just showing the lone pairs of electrons. Okay. Now with chlorine, if I'm to talk about this, it has 7 electrons in the outermost shell. Okay. And so with 7, it has used 1 to bond with another chlorine, like how you can see. Okay. And so it will have a balance of 6. So this balance of 6, they are the ones which make their own pair of electrons. So that's why you can have one lone pair, another lone pair, another lone pair, another lone pair. Even here, one lone pair. So that one. Now, the iron having a high charge density, a high polarization power, it is the one that attracts the electrons on chlorine. Okay? On chlorine. And so when you attract the electrons on this chlorine, then the chlorine also ends up pulling or withdrawing these bonding electrons towards itself, and then the overall effect is distributed to the other chloride atom. But now for me, the reason why I prefer complex, the Cl, okay? Then you write this is partial charge. The reason why I prefer this, and then you write partial charges, okay? And then you can write Cl3, and then you write the Cl, or you can do this Cl, okay? Then partial charge, and then you write Cl, and then with your iron 3. iron, and then Cl3. You can do this, and then you put partially positive here and partially negative here. So whether you do this, whether you spread the bonds and you show how the bonds will be here, whether you do this, it is still the same thing. But for me, I prefer this. This is a 4. Let's make this 4, and then with a partial minus here and a partial positive here. Now this is not there. Now may I prefer this because the polarization of iron to this chloride bond is not strong enough to induce charges, sorry, to form complete charges, that the Cl will now completely break to form ions. Okay? Until when this electrophilic chloride atom receives the electrons, okay, that's when it will completely break, okay, to form the ions. But before that, it remains as partial charges. Okay, so there is no harm for you to write this, and there is no harm for you to write this, and there is no harm if you still want to spread and you show the bonds. Still, there is no harm. Okay?
Okay.
Yes. Now, once you understand this concept, then the rest of work becomes easy. The rest of work becomes easy. Now, with alkylation, this one just refers addition of an alkyl group. Okay? Addition of an alkyl group. Okay? To a benzene ring. And there are two methods of addition of an alkyl group to a benzene ring. In one, we can use an alkyl halide in presence of a halogen carrier. Okay? There we shall add an alkyl group, or we can react an alkene, okay, with benzene in presence of a mineral acid. Still, it's the same thing. We shall add an alkyl group to a benzene ring. And those two reactions, they were studied by this guy, okay, called Friedel Crafts, and so they are known as Friedel Crafts alkylation. And the mechanisms, they are also simple. Oh, I clicked when I didn't want. So let's start with the first one, where we shall use an alkyl group. Okay. So where we shall use an alkyl halide. You can also do the mechanism. Okay. For example, you have this as your benzene. I said I'm sorry for the benzene, but it's because I'm using a touchpad. But with a pen, I always, also with a chalk, I usually write good benzene, good rings. So I write, I react this benzene with an alkyl halide, maybe CH3, Cl, in presence of a halogen carrier, which is maybe iron 3 chloride. Or it can be CH3, I've given you chlorine, but in an exam, if I change and I put the Br, then some people complain that teacher, you've never taught this. So it can be CH3, CH, CH2, Br in presence of iron 3 bromide. Okay, iron 3 bromide. Then we shall form an alkyl halide. Sorry, an alkyl benzene. Alkyl benzene. So we have this. Oh, when you are given circular, when you are given the ring structure, the one which shows delocalization, you should maintain and don't do this. So we shall have CH3 here, and we shall also have so I'm trying to draw some good benzene so that you don't complain. Now, like I told you, this circle should be big enough. I think I cautioned you some time back this. Some people want to do this. You write this and then you draw this as your circle. Now this is not correct. This circle must be big enough, okay? Because it shows delocalization of electrons. And now can this one be delocalization? I don't think. And then CH2. Oh god, sorry for that. CH2 and then CH3. So can you write the mechanism? I know you can do this. Hurry up. Write the mechanism. Now I'm going to rub. If I cancel, I'll rub. So write the mechanism. The mechanism is the same as that of chlorine. So please hurry up. So yeah, your mechanisms were okay. Actually, this time round, you passed. Okay? So the first thing that happens is to form an electrophile from this. And since this is a halogen carrier, then it will induce this to form the electrophile. So the CH3, okay, and then Cl plus the iron 3 chloride, okay, it will take away the iron, will take away the electrons, okay, to form our C3. So the bond doesn't break there and then, okay, but you will induce the formation of partial charges and the bond partially breaks. So if you want, you can still represent it as F3 SCl, okay, and this is 3, and then you have partially negative and partially positive on the benzene. So now this electrophile here that is formed, okay, it's now the one that receives the electrons from benzene, okay, it's now the one that receives the electrons from benzene, and we are given this benzene, so it should be maintained. So CH3, okay, and then this is partially positive, and the partial positive is on carbon by the way, not hydrogens, okay, and then Cl, and then iron, Cl3. So this one, okay, I prefer using a different pen for this. So this one takes this, and then this goes, okay, and then we shall form we shall form this. So this is Cl, and then the H. Now with a ring, since we are given ring, then we shall, so you have to represent that with a ring, and the ring faces where the Cl has been attached, plus our iron 3 Cl4, and then minus. Then finally this will come and take off. It will take away the hydrogen atom, and then the 2 electrons that form this carbon hydrogen bond, they will be donated back to go and resonate to go and delocalize, okay, with these pi electrons within the ring, so that now you form a, what am I doing? This is CH3, sorry for that. So that you form your methyl benzene, okay, your methyl benzene, okay, you form your methyl benzene, and your hydrogen chloride. So it is as simple as this. Then with alkenes, in presence of amino acid, the same thing happens, okay, you synthesize an electrophile, okay, and then after you synthesized an electrophile, and then it is that electrophile that will receive benzene, so that will receive the delocalized electrons from benzene, okay, to form, to undergo a reaction, okay, a substitution reaction. So this is basically simple. You do this mechanism, So we have our benzene, we have our benzene, which is, now this time around, let me give you this, so our benzene, it will react with the, let me give you, okay, let me try to complicate things a bit, with CH3, CH, okay, and then double bond, so there is a, no, and then CH2, and then in presence of amino acid. So can you do this? Let me, no, I won't give you the product. Can you do that? Chop chop, chop chop. Okay, yeah, thanks for that good work that you've done. Now, here we have two possible products, a major one and a minor. So you can form this, okay, don't mind about these crosses, what is crossing. You can form this, CH2, and then CH2, and then CH3. You can form this and it will be formed, but also you can form this. You can form this, this one and this, okay, and CH, okay, and then this is CH3, and then this one is CH3. Now all these ones can be formed, actually not can be formed, but they are formed, but one is a major, another one is a minor, and this is the major compound, and that's what we mark. We mark the major compound, and this one is a minor compound, okay, and this is not marked. You may find when you form like 90% or 95% of this, then only 10 or 5% is going to be this. So therefore this becomes the major product, and this one a minor product. Now, what is governing what? What is governing the formation of which product? I'll still take you back to Markovnikov's rule, okay? Markovnikov's rule, Markovni, or you can say Markovni, I think it's Markovni, or Markovni, depending on what you want to write. Markovnikov's rule, and then carbonium ions. So if we explained this science so well, okay, we explained this science so well, Okay, so where that what's up with this now this one is supposed to be a sulfuric acid or HCl, a mineral acid, that it will ionize to give you hydrogen ions and hydrogen sulfate ions. Now the hydrogen sulfate ions, okay, this is OS, okay, this is 4. The hydrogen sulfate ions, they are the ones that will complete where you were stranded, what you are stranded with, okay? Yeah, so sorry for that. So the carbonium ion, we have what we call primary. We have ever discussed this work and the video is there. We have secondary and we have the tertiary. Now the tertiary is more stable than the secondary, and the secondary is more stable than the primary. And where you have a chance of forming a secondary and a primary, you will form a secondary. Okay? But also where you have a chance of forming a tertiary than a secondary, then you form a tertiary. So now here, the first thing that will happen is protonation. We shall add a proton on our alkene to form an electrophile. For instance, we shall have CH, and then CH, and then CH2. Okay. Now plus hydrogen ions, okay, whereby the hydrogen ions will receive electrons from this. Are you seeing that? Now the hydrogen ion can add itself here, and when it adds itself here, according to Markovnikov's rule, it will form a secondary carbocation. Or alternatively, it can add itself here. Okay? And when it adds itself here, it will form a primary carbocation. But a primary is unstable than a secondary. So where you have a chance of formation of a secondary over primary, then you form a primary to, so you form a secondary to a primary. So as a result, the hydrogen is going to add itself here, and you have a secondary carbocation. So we shall form CH3, okay, and then CH with a plus, okay, and then CH3. As simple as that. Now once you form a tertiary, so the secondary carbocation, then you have your electrophile, and now benzene comes in. Okay, the benzene comes in. We have this, so it's what we shall still maintain. So this one is CH3. Whichever way you write it, it remains the same. So this is CH, and then this one is CH3. And you have a positive charge here. So now the benzene is going to donate its delocalized electrons to our carbon that is electrophilic. So this is what we shall form. And so what shall we form? We shall form our benzene, okay, with a charge, a double bond here with another bond. Then this one has a plus. And then you have your group, okay, the CH3, the CH, somebody wrote this. This is good. Okay, and then a 2 here, because there are 2 methyl groups plus the hydrogen. Now the other nucleophile that was generated, because you can't have hydrogen ions, just hydrogen ions. You have hydrogen ions together with a nucleophile. Okay? Then with your nucleophile, it could be this. Okay? Then the nucleophile is going to take away the hydrogen. Okay? And then this bond is given back to the ring, okay, for delocalization. To delocalize with other electrons. So the product is going to be your benzene ring. Okay, so this is the major product, which is CH, okay, which is CH, okay, and then CH3, and then A2. So it is as simple as that. So when you have this, then this is not correct because it's a minor product. Not so? Yes. So now, what we are remaining with as far as benzene is concerned, we are remaining with just practicing. I've given you almost all the concepts now. Now, we are remaining with practicing, and we shall do more of practice, okay, for these proceeding lessons. So otherwise,